In this video series, we're going to look at lesson 8.3, which is logarithms and logarithmic equations. Now, this video is going to cover the lesson in 3 parts. Part 1 focuses on converting and evaluating logarithms. It really deals with what is a logarithm and what does it equal. Part 2 of the video is going to look at the different properties that associate with logarithms on it. How do we merge logs together? And then part 3 puts it all together with solving logarithmic equations. So let's start off with part 1. Is when you see the word logarithm, and I see logarithm, or I see the word log, rather than seeing it as logarithm, I'm going to ask this question. I'm going to ask, what power of blank gives you blank? This is really what a logarithmic expression or logarithmic equation is equal to. If I say the word log, I'm going to focus on what power of. So really a logarithm is a fancy way of looking at powers. And so if I have the converting between exponential and logarithmic forms here, now I'm using different variables than some other teachers, and I'm doing it for a reason. I'm doing it because I want to use b, because b is your base on it. So if I look at the example to the right, my base is 3. And then I have p, and I'm using p for power. And so in this case, my power is x. And I'm using n for just number. And so in this case, 243 is my number. And so that's exponential form. We're used to that from the previous lessons. Now what logarithmic form is take that same expression, rather than write it as 3 to the x plus 243, we can evaluate it by using the word log. So I have log, which when I say the word log, I'm thinking what power of. And if I look at it, my base is a subscript there. So my base goes here. So I have log, and my base is 3, base 3. So look at that. When I see the word log, I say what power of. So log, nope, not log, what power of 3? So log base 3 is really the question, what power of 3? Gives you, the next part is your n. So my n here is 243. That's my number. So let's read it left to right. What power of 3 gives you 243? I'm going to put my equal sign, and let's finish it off. Well, it equals your power. So what power of 3 gives me 243? And right here, it looks like the power is x. So I say it equals x. They are equivalent when it comes to what they mean. It's one question. What power of 3 gives you 243, which is really even what this question is. You're asking, what power of 3 gives me 243? We're just writing it as a logarithm. So anytime I see the word log, I'm going to ask what power of blank gives me blank, and that's going to fill it in. I can answer that question by finding the power. So the next part is practicing with the converting. And I'm going to go left to right on this. I'm going to draw this line to separate them. Let's focus on the right side first. We're comfortable with exponential. It's something we're used to. So if I'm going through and I'm looking at this, I have 4 cubed equals 64. 4 is my base. 3 is my power. And 64 is my n. So if I look at it and I read it, what power of 4, because that's my base, gives me 64, because that's my number. And what does it say the power is? Well, it says the power is 3. So how do I write that as a logarithm? Well, I read the question. what power log of 4, so log, I'm going to keep the color coding, base 4, what power of 4 gives me 64? And I can answer that question because it tells me the power is 3. So log base 4, 64 equals 3. That's converting. So when we think about it, we're going to take this idea on it, and we're going to use it here as well. What power of, well, that's my base is 3. What power of 3 gives me 1 over 27, because that's my number. What power of 3 gives me 1 over 27? It tells me that power. It tells me it's -3. So now let's write it as a logarithm. What power log of 3, so my base is 3, gives me 1 over 27? That's easy because it tells me that power is -3. So that's converting from exponential to logarithmic on it. It's a question, and that question is crucial for understanding exponential and logarithm. What power of blank gives you blank? And we could do it the other way as well. What if I go from logarithms into exponential? What we have to remember is the format is still the same. It's log, your base is down here, your number, and then it equals the power. So what power of my base gives me my number? That's what we're going to use when converting from logarithmic to exponential. Let me just copy it down here to the next one. All right, so what power, when I see the word log, I read it as what power of, the first part is 125. What power of 125 gives me 25? Well, it tells me the power. It tells me the power is 2/3. So let's write this as, I'll put P for power. Let's write this as an exponential. And exponentials, I have it right over here, are base to a power equals a number. So what power of 125, and I'm just going to put a question mark right now, gives me 25? And I can answer that question mark. I know what it is. I know it's 2/3. It tells me the power. So what power of 125 gives me 25? And that is 2/3 on it. And this should be a little bit lighter green. There we go. So next one. Log, what power of 8 gives me 2 on it? And so we're going to go that way. What power of 8 gives me 2? What it tells me? It tells me that power is 1/3. That's your power. So what power of 8? So 8 to some power gives you 2. But we're told that the power is 1/3. That's converting between logarithmic and exponential logarithmic. It's a question. You need to know the terminology, base, number, power on it, and where they go for each one. And that's kind of what this part outlines for you. So the bottom line is, what does a logarithm equal? What is a logarithmic expression equal to? And if I look at it right here, what is a logarithmic expression equal to? A logarithmic expression is equal to a power. That is what every single thing was equal to when we did the converting. It was always equal to a power. So I could say it's equal to, and it says and, so an exponent. Or I could think of it as a power. And that's where all the stuff we've kind of been going through is, it's log of your base. What power of blank gives you a number? And you're trying to find out what is that power. each time. That allows us to do very simple evaluating on them. When you're evaluating them, the idea is, and I'm not going to set it equal to x. I've stopped using x because I don't think it helps us understand what is a logarithm equal to. It's equal to a power. So I'm going to set it equal to p instead of x. So that way I know it's a power. So we're going to set it equal to a power. So let's do it first as we walk through these steps. So log base 7 of 149 evaluated, so it equals p. I want to find what is that value. It equals a power. Well, then convert to exponential form. So 7 is my base. I'm going to use the colors instead of writing it all down. Now you can refer up to this on it. 7 is my base. 1 over 49 is my number. And I have my power. So what power of 7 gives you 1 over 49? So my base is 7, and it's going to be attached to that power. So 7 to some power. What power of 7 gives me 1 over 49? That's, again, converting to exponential form. Now we solve, and I'm going to leave it as power just so we can understand what we're dealing with. Now when we solve, we're going to find a common base. That was what we dealt with in previous problems. So for solving, what we want to do is we're going to think about how can we get both bases to be the same. And I'm going to want them both to be 7 on it. It's a smaller number, it's easier, so 7 to some power. My job is I need to change 1 over 49 into 7 to a power. And remember, if it's a fraction, we kind of just ignore the fraction. Think of it as 49 is 1 over 7 squared. And remember, a fraction is a negative exponent. And once I deal with that, once I deal with creating that common base, I can do the same thing we did before, which was cross it out, and I get my power equals -2. That's it. It's applying all the stuff we've previously done in Chapter 8 together. So if we look at, I'm going to go down because these ones kind of more relate to each other. And I'm not going to write power every time. I'm going to use P. I did it for the first problem, so it kind of helped us make sense. So I want to evaluate the log, so I want to find out what is that power. Again, same color coding as shown up here. I'm going to make my base blue. This is my base. What power of 5 gives me 125? That's what I want to know. So 5 is my base, and it's going to attach to that power. So what power of 5, right there, 5 to the P, what power of 5 gives you 125 on it? And so it gives me 125. An equal sign. Well, again, I want to find a common base. Well, the common base between 5 and 125 is 5. 125 is 5 cubed. And so I can cross out the 5s. I get P equals 3. My power is 3, and it should make sense. Think about it. Ask the question. Power of 5 gives you 125. Well, 5 cubed is 125. So that logarithm has to equal 3. Now this one may look like it's trickier, but we're going to always ask the question. What power of blank gives me blank? I'm trying to find what is that power. So I'm going to set it equal to P. And I'm going to identify all my parts. 4 is my base. My number, I'm just going to leave it alone as 4 squared. And you're going to see why. And my power, P, I'm trying to find. So my base, what power of 4, so 4 to some power P, gives me 4 squared. I mean, just look at that. What power of 4 gives you 4 to the second power? That's really what that question is asking. And you cross out the 4s and you get P equals 2. It just makes sense that what power of 4 gives you 4 to the second power? Well, 2, because that's second power. So that's how you evaluate a logarithm. You have to insert the equal sign, and I want you to use equals p. And for this one, I'm going to go back to power on it. Now, the right side is a little more tricky. It involves a little more difficulty on it, not quite as straightforward with the common basis, but it's still something we've already covered. I look at it, what is my base? What power of 9 gives me 27? It's not a direct power. So what power of 9? So 9 is my base. It attaches to that power, and it gives me 27. All right, so well, 9 to the first is 9. 9 squared is 81. No, it's not going to be a nice one. It's going to be a fraction on it, so or a decimal, so I have to do some math. So I want to create a common base. Sometimes I need to do it between both of them. So in this case, let's look at 9. I know 9 is 3 squared. That's not bad. So 3 squared is 9, but remember, I still have this power here. So twice, and I'll use p and go back to that. So equals, well, 27. Can I write 27 as 3 to the power? So 27 is 3 cubed. I can't create a common base. I just had to change both of them, like we did before. So cross out the common base, and I get 2p equals 3. So p equals 3 halves. There's your power. 9 to the 1.5 power is 27. So it's still the same idea as the left column. We just need to find a common base between them. So logarithm equals a power. And I go back to p. So log base 16 of 64 equals what power? So what's my base? Log base 16. My number is 64. So I want to add my base to the power. So what power? So 16 to some power p, we don't know what it is, equals 64. And so my job is to find out what that is. Well, 16 squared is 256, so I can't change one base. I have to change both of them. So 16, I know that's 4 squared. So I have 4 squared, but remember, I still have this p here. So boom. So 4 to the 2p equals, now let's see, 64. I think that's 4 cubed. So boom. Now they have the same base. I can cross them out, and I could say 2p equals 3, and it just so happens that this is also 3 halves on it. So the right column is a little more trickier because it's not as straightforward with the common base. On the left side, we see 7, and we have 49. We see 5, we have 125. We have 4, we have 4 squared. The right column ones are, you have to create a combination of both of them. Now, my favorite on this is number 5. And because it's a constant. So boom, log base 7 of 1 equals what power? So I'm going to read it as the question. What power of 7 gives you 1? Well, let's try the conversion. 7 is my base on it. 1 is my number. My base attaches to the power. What power of 7, right there, 7 to some power, equals 1. Well, 7 to the first is 7. 7 squared is 49. That's going the wrong direction. And 7 to the first is 7. 7 squared is 49. I'm getting skin too big, so let's go backwards. What's 7 to the 0 power? Well, that's 1. This is actually a definition. Anything to the 0 power equals 1. My power is 0. That's why I like this one. It's the idea that if you have a power and you apply 0 as that power, it's going to make the expression equal to 1. So this is part 1 of the video. It deals with just converting and evaluating logarithmic expressions.